Okay, so now we're going to see how to make constructions using paper and pencil. And I'm going to show you a couple of things. First of all, how you can get some information on how to do this. So let me point out for you right here, if you go to Khan Academy, of course, that's this little link down here in your doc. And if you click it, you will open up a Khan Academy page that looks something like this, okay? And what you should do is just sign in with Google, okay? When you sign in with Google, it's going to ask you which account you're signing in, and it's going to ask you to allow, and you're going to say allow. And, it's going to get you signed in. And we're going to look for something called Compass. So up here, you're going to hit Compass Constructions 1. Now, the point here for this exercise that we're looking for, Compass Constructions 1, is that it's going to give you an opportunity to kind of practice, because sometimes doing these things by hand can be kind of tricky. And here they're wanting you to construct an angle bisector for the given angle. So just to show you how that works, if you click Add a Compass, it doesn't actually give you the compass tool, it just makes a circle for you. And you can place your circle anywhere you want. So if I place my circle, I can place it with a center there, and then I can, just change the size of it. Now this is a lot easier for most people to do than it is to actually create, to create another, to do it by hand. But we're going to see how to do that as well, okay? And then what we would do is we would want to connect. Well, what we'd want to do is we're creating a circle here, and the point of it is, the definition of the circle is, one of the definitions of the circle is that all these points on the circle are all equally distant from the end point, or from the center point rather. Okay, so this point here, where it intersects my angle, is going to be equally distant from that point there, where it creates my where it intersects my angle as well, this side of the angle, that ray there. And so, I could just make my circle and just, it doesn't really matter the length that I choose here. I'm going to go ahead and add another compass, and I'm going to place the center where these guys intersect. And I'm going to make the radius equal to this length, so that it should go through the center of the other circle that I had right there. And that way I know, like, this point is, it's on this circle, this blue circle this circle right here. So I know that this point is, the same distance away as any other point on this circle. But notice where it intersects, it's also on this other yellow circle that I'm looking at now. And so it has to be just as far away from here. So intersection points with circles are really handy, because they allow us to say, hey, we know that the points where they intersect are equally distant from both centers. They're parts of both circles. So these measurements here have to be the same. Let me add another compass here and place it at this point where that circle, that original circle intercepted our angle. And then I'm going to make sure that the radius is such that it goes through our center as well. Okay, so now what we have is we have three circles, right? And this point here is going to be equally distant from this intersection point here, this side, and from this side. Okay, so if I were to place, now I'm going to add a straight edge. If I were to place a point there, I'm going to watch how this works. I'll place a point right there. That point should be the same distance, because it's on this circle here, as it is from this center, because it's on that circle there. So it should be the same distance from both of those sides. And now if I put this point down here, this point is also going to be equidistant from this circle and let's see, not that circle, okay? And because of that, if I drew a triangle, like from here to there, that little triangle, this triangle is going to be, have the same length here, the same length here, as this triangle if I drew this one. 1, 2, and 3. These would be the same length, right? And we already proved, and these are the same lengths here, right? Now the middle length, or the middle side of those two triangles, is also the same length. So we basically end up with two triangles right here. 1, 2, 3, and this triangle 1, 2, 3, right? Those two triangles are going to be congruent to each other. They are equal in every way to each other. And that tells me that the measure of this angle must be the same as the measure of that angle. And so I can practice here on Khan Academy, and if I've constructed it well, you know, when I hit enter there, it will tell me that I did a good job and let me practice some more constructions. Okay? If you want to learn how to, these videos over here can show you how to do these things. You know, how could I make a line that's parallel to the given line that goes through P? Well, think about that. Now, how would I make sure, right, that I have a circle here that is going to be, you know, think about that. How would I make sure that, knowing that this distance here is, you know, I'm wanting to have another circle that has the same distance. Let's think about that. I could make another circle here. I know that the distance now, if I stretch that out, the distance between here and here is the same because it's part of this circle, and it's part of the this other circle. This distance, boom, boom, right, has to be the same as this distance. And now I know that my point out here, any point on this line, is going to have to be the same distance away from my line as this point is. So the only thing I got to do is I've got to learn how do I make a perpendicular line. Now, a line that's going to be perpendicular, that's going to go through this. We should watch that and see how to do that. Okay. What I would do is make another circle, and then I could construct the perpendicular that goes through that circle and through this line as well. But I'm not going to do that just yet. I am going to let you kind of figure that out. Okay? Anyway, watch Khan Academy or search for more videos that shows you how, and you know, I want you to work on that and try to figure out how. So now I'm just going to go over the paper and pencil stuff so you can actually see. I'm going to show you the paper and pencil stuff so you can see how it's done by paper and pencil. So let's look here. This is a, you know, a paper here. I'm going to show you how to, you know, how we can find a perpendicular line to a segment. Well, you know, what I'm using is I'm using a straight edge here. I've got one of the rulers. I'm going to take a pencil over here, and I'll just construct a segment. And I'm not really measuring right now my segment, although, you know, I could probably see how long it is if I just look. You know, it's approximately 4 units there, but anyway, I've just made a segment. Well, what's important here are my endpoints. So my endpoints. So now what I want to do is I want to find a perpendicular line, a line that will go through this circle. So what we use to do that is this tool. This tool is called the compass, and we're going to slide the pencil in here into the compass. Okay, and what we're going to do is I'm going to set the distance. This is used for drawing circles, so I'm going to make my distance. I want to be able to hold this, you know, straight up, but I'm going to set my distance here to something that I know is a little more than halfway, and then I'll snap my pencil in. See, I slide my pencil in, and then I snap it in, and I'm going to hold it here, and then I'm just going to create a trace. Now, this is tricky to do. Okay, some people like to move the paper, but I am just going to try to do it by twisting the compass. So again, what the compass allows me to do is it helps me to construct the points that are all equidistant from the center, right? So now I'm going to come to the other side, and this is really important. This length was not critical. I selected that length randomly. I just wanted it to be longer than halfway. But now that I've set it, I cannot change it. So I'm going to come over to this side without changing that length and place my point here on this endpoint, okay? And then I can twist again, and I'm going to cross those just draw this is an arc, which is a part of a circle, right? So I'm just going to draw my arc until it is long enough to cross the other arc, right? So now I have constructed two parts of a circle, or two arcs, right? And then what I can do is I can use my straight edge to finish solving this. So I take my straight edge, right? And what I'm going to do is I want to draw the line that connects these intersection points. So I would go ahead and lay my straight edge out, right? And then we're going to just draw the line that creates that. So what happens is this line here, if I drew it right, let's make sure I've got that good. And I'm going to just try and make that maybe just a little bit longer, because I'm going to try and measure it here. Oops. Okay, there's my line there. So this line does a couple of things. First of all, you realize that this length here, let's see, what did we decide? We decided, since this is on the circle, that this length from here to here has to be the same distance as this length from here to here, because they're both on the circle. Both these points are on this same circle. So we're using the definition of a circle to say these lengths here have to be the same, right? And then over here, because we used the same length circle, we knew this side and this side, they have to be the same lengths too. So in other words, this point where it intersects, it's on this circle and this circle as well. So this point has to be equidistant from this end point. I'm going to draw this with a dotted line now. I'm just kind of giving you the idea. And over here to this length, this has to also kind of be, those two sides right there, this side and this side, have to be the same length. I could do the same thing this direction. And guess what? Any point here is going to be the same length away from these endpoints. And we'll learn that later on. But what we should know and look at right now, if we take our compass and if we set the center, I'm sorry, this tool is called the protractor. We want to set the center here of the protractor right at that intersection point. Then we want to make sure that it is lined up. This says 180 degrees. Oh, I'm holding this upside down. Let me try turning that over. Let's do that again. So we place this at our intersection point, and then when we line the line up so it comes right across here to 180 degrees, we should be able to measure the angle that this forms. So we come right through here. If it was over here, then this angle would be, that says 80. It's kind of hard to see, but that means an angle that came from here, went to there, and went up there would be an 80-degree angle. If it came out, if it came out right there, that'd be 80 degrees. And obviously the opposite angle, which is this one over here, would measure 100 degrees, right? But the one that we're looking at right here goes right straight through the 90 degrees. So we have constructed right here a perpendicular line. Okay, so that's what it is that you're going to do. Make one of these perpendicular lines and take a picture of it. Also, go to Khan Academy and complete Compass Constructions 1. It says get 3 correct in a row. So I want you to work through Compass Constructions 1, get 3 correct in a row, and work through making this construction. You can just do this one construction would be fine, and take a picture of it. If you want to do more, you're certainly welcome to do more. Okay, but you're going to want to take a picture and make sure that on the picture you put your name. So this one was done by Mr. T. Okay, you put your name next to it, and you'll show that you could indeed do that. And the picture and the work done on Khan Academy, you should do a screenshot that includes your name and shows that you did get 3 correct in a row. Those can be published in your binder as digital artifacts of your work. Okay, we're done.